So I'll be sharing my screen now. Okay. Sorry. So I think my screen is visible enough now, right?
Yes.
Okay. Right. So in our previous classes, we started with data analytics and the difference between data analytics, data science, and statistics, right? And today we continue from where we stopped. And if you have question, you can put your question in the comment section. So I will see there and attend to it accordingly. So when we say a particular decision is a thoughtful fact-based point of view. It simply means the decision you're making, you're supporting the decision with data. And when you're making a decision, you have data to back up your decision. In that case, we can say this thing is a fact-based point of view. All right, and we also explain what a data is. When we say data analytics means two words. It's combination of two words: the data itself and the analysis or analytics of this data. And when we say data, data is an information that is gotten from field. All right. So we explain all of these things in our previous classes. And we also explained that statistics is a particular important part of data analytics. So we explained the role of statistics in data analytics, and we also explain the two sets of statistical tools. We said two set of statistical tools when we say statistics. So statistics, there are two sets that are very important, or two tools that are very important for as a statistical tools. The first one we explain is to be descriptive statistics, descriptive, and the other part, we explain this to be inferential statistics. So when we say statistical tools or statistics generally, there are two parts to it. The first part is descriptive. The second part is inferential. And when we say descriptive means a way of identifying important elements in our data set. So when we have a data set, the tools we use to identify important elements in our data set, that kind of statistical tools is called descriptive statistics. So in descriptive statistics, it helps us to identify important elements in our data set. So when we have the data set, to identify what are the important things or what are the dots in this data set, we use descriptive statistics to do this. But when we say inferential, inferential because it is not enough for you to identify those important elements. It's just for you. It's also for you to know how does this particular aspect, how does this element affect the other element. So how can you explain one element in terms of the other element, or how can you connect those elements together? How can you relate those elements together in your data set? And what help you to do that is not descriptive, it is inferential statistics. So while descriptive statistics help you to identify important elements in your data set, inferential statistics helps you to connect or relate those important elements, or helps you to relate one element that you have identified already with descriptive to another element. That is what inferential statistics does. Let me give an example of important elements in a data set. For instance, we can say mean. Mean is an important element you can actually get from our data set. For example, let's if you have an information about a person, let's say we have a data set that is in tabular form, and the first one we have the name, we have the age. All right. Let's say we have states. Now, so let's say we fill out the name, we fill out the age. So someone can say, what is the average of the age? And when we say average of the age, we're talking about the mean of the age. And then in this case, the mean simply means the representative age of all your data sets. When you have a particular data set, or you have a particular column, or for example, in a group or in a class, and someone says, or you want to find a single age that represent the age of all students in your class. So that particular data you are actually asking for is the mean. So mean is that particular information that gives you the representative of that particular data set. So one part of data set that will represent all other data set is the mean of that data. or that particular information or that particular group of data. All right, so that is that about mean. And another thing in discrete statistics, you can say we want to get the median. All of these things, they are all descriptives. You can say we want to get the variance. We explain this later. You can say we want to explain standard deviation. So all of these things are elements that we can actually identify using descriptive statistics. There are more to this anyway. But how does one affect the other, or how can we use one to explain the other, or how can we use this particular element to explain or to give information about our data set? We won't be able to do that in descriptive, but we can easily do that using the inferential statistics. Let me give an example. When we say population gives it actually gives the information. Population generally is when you consider every element in your data set, every element in your particular in your research area. For instance, let's say Lagos State. I want to carry out a particular research in Lagos State. If I consider all the population, every individual that are in Lagos State, I can count them one by one, everybody without an exception. Then in that case, we say I have made a population. So that kind of data set is population. But to be realistic, population is not easy to get. In your data set, we can't say we want to carry out a research in Nigeria, then you have to consider each and everyone in Nigeria. That is not realistic. So most time when we're dealing with our research, we usually make use of sample. So when we say population, every individuals or every row in our data set. But when we say sample, we are actually referencing some parts, at random in our data set. For example, I want to carry out a particular research in Lagos State. I can just choose some different location in Lagos State at random. I will now carry out my analysis on this. Then after that analysis on the sample data, this is the population. Then I can pick some samples at random. Then those samples, I will now make my research. I will carry out the research on each samples. Then I will now infer a generality on the entire population. So I can research each individual samples at random. But if I'm making a particular inference, I will now make inference based. I will not generalize those inference based on the entire population. When you try to do that, when you try to carry out particular research, or you carry out a particular analysis on statistical or on sample data, and you now infer your properties or on the population, that kind of statistics you're taking is called inferential statistics. So that's the descriptive statistics, and that is inferential statistics. So in a simple way, descriptive statistics help you to identify important element or helps you um to to get the dots in your data set or to find the dots in your data set, while inferential statistics it helps you to connect those dots, or it helps you to explain each of these elements in relationship with other elements. So that's that about that. Now, but one thing about our data is in a realistic settings, when we say data, recently we can see that data are being produced every minute and every second. A lot of data are out there. That's actually what led to big data, right? Because the data that we are producing every day now, they're so enormous that even a simple database won't be able to accommodate this, which actually led to big data. But when we say this data, even though as enormous as they might be, they are not always in the kind of they are not always in the kind of format we want them to be. So most time when you're dealing with your data set, you're collecting your real raw data on the field. Most time you still need to do some cleaning before this data can actually be right for your decision making. And when we say you're dealing with unclean data set, there are some things we look out for when we are dealing with our data set. So when we say our data set, what do we look out for when we have a data set in front of us? Because remember, our data sets won't always be in the kind of format that we look out for. So what do we look out for? Some of the things we look out for in our data set is missing data. So most time or sometimes the data set we are collecting or we are downloading or we are buying, sometimes it might contain what we call missing data. All right. So beside missing data, we can also have what is called an outlier. I will explain all of these things later. And when we say an outlier, and when we say an outlier, all right. So when we say an outlier, it can actually be genuine. Outlier can actually be genuine, or sometimes it can be erroneous. So which is due to error. Another thing we deal with in our data set is what is called duplicate. So we also deal with duplicate. So duplicate. Why the last thing, or for now, the last thing we deal with is what is called but because what's the last thing we deal with when we're dealing with data set?
The last thing.
Yes.
Yeah, that's an outlier, duplicate, and big data.
What's this big data? There's not big data. What we have is bad data.
Okay, bad data, bad data. Bad data.
Now, all right. Okay, thank you for that. So when we say missing data simply means some part of your row are missing, not the entire row actually, because if an entire row is missing, sometimes it can actually be entire row anyways. But this is what I'm saying when we say missing data, it simply means one column of your row of a particular row is missing. So if you have, let's say we have information about demography of person, let's say we have the name. So let's say we have a demographic data, we have name, we have age, we have state, um, we have height, let's say height as well. Then, so let's say for the first column, we now have the name is Hadi. So let's say we have Hadi, but in this Hadi now, when Hadi wants to fill, okay, we have gender as well. Let's add gender. So let's say Hadi is 15 years old. The state is let's say the state is let's say Lagos State. Then the height is missing. Hadi did not fill his height, maybe because he doesn't know his height. Then the gender is male. So in this case, since a particular column is missing in our entire row, in our particular row, then we say there is a missing data here. So most time when we're dealing with missing data, what we look out for is simply means one of the column of a particular row is missing. Sometimes it can actually be more than one column, maybe two columns are missing in a particular row. So that is what we call missing data. So when we say we have a missing data, it simply means some part of our data is actually missing, or sometimes the entire particular data is missing. So that is missing data. So how to deal with missing data? We look into this later. Another thing we actually have, or we can have, that is an issue when we're dealing with our data set is an outlier. So when we say an outlier, outlier simply means some a particular value in a data set is higher or far higher than the other part of the data set. Let's say particular value in our data set is significantly higher compared to other parts of our data set or compared to other values in our data set. For instance, let's say we have a particular class in a class of students, and some of the students we have the age to be 21, another person the age is 25, another student we have the age to be 22, another student we have the age to be 20, we have another one to be 18. We now have a particular student that the age is 95. In this case, this 95 compared to other part of the data set, then we say 95 is significantly higher than every other person. The 95 is said to be an outlier. So sometimes outlier doesn't mean it is high. We can have something that is very low compared to other particular data set. For instance, in this particular data set, we now have another person that the age is just 5 years old. Then in this case, 95 is an outlier, 5 is also an outlier. So that's what we mean by an outlier. Outlier simply means a particular value is significantly higher or sometimes significantly lower than every other part or than other values in our data set. So that is what an outlier is. And the truth about outlier is outlier can actually be genuine. Sometimes it can actually be erroneous. When we say outlier is genuine, actually we have that the value is true in a data set. Let's say, for example, in a particular class, there's actually someone that is 95 that's also taking that particular course with us. In this case, 95 is an outlier, but this kind of outlier is a genuine outlier because the data is actually present in our data set. But sometimes you can actually have erroneous. Erroneous means the data is not there. Maybe due to data collection, we made that mistake when we are collecting our data, or maybe data input or data entry, there is an error when they're actually inputting that data. For instance, let's say this 5 is not there. Let's say, for instance, maybe the person actually wants to write 25, but mistakenly input 5. Or when we are collecting our data, we mistakenly collect 5 instead of 25. Then in this case, we say that 5 is an outlier, but this kind of outlier is an erroneous outlier. All right, so that's that about outlier. Another thing we can have is duplicate. When we say duplicate, it simply means two rows that carry the same values. That is what we call duplicate. It doesn't mean maybe two columns that have the same value. It simply means two rows. For instance, the first row here is Hadi, age is 15, the height, the state is Lagos. Let's say the height now. Let's just fill in the missing value now. Let's say the height is, let's say 5 point, let's say 5.9 is the height. The gender is male. We now have another row, and the row is also Hadi. The height is still 15. The state is also Lagos. The height is also 5.9, and the gender is still male. Then in this case, we say there is a duplicate data here because two rows carry exactly the same data. So that is what we mean by and how a duplicate data. It doesn't mean when we have, for instance, we can have another column where this one is let's say this one is higher. For instance, higher. The age is 15. Now, the state is Lagos. The state is Lagos. The height is 5.9. The gender is male. In this case, the second row and third row are not duplicates because there is something there is a difference between these two rows. So in this case, now we see there's one duplicate here. Row 2 and row 3 are not duplicates because there is still a difference there. So that's what I mean by duplicate data or duplicate data or values in a data set. When two rows carry exactly the same value, that's a duplicate. The last thing we talk about, which we'll look into later, is the bad data. When we say bad data means data that is not real. For instance, we are carrying out or we collect data about age, and in this particular age, we now see minus 18. We know this is a bad data because automatically age cannot be negative. So in this case, automatically this is an erroneous data. Maybe the person wants to write 18, and the person, due to error or mistake, the person puts minus 18. So that kind of data that we know this data cannot be real is a bad data. All right. So that is that about what we look out for when we want to carry out um our particular data set. All right. So that is that about that. Any questions so far? Any questions so far? Are you there? Okay. So let's move on. So it seems there is no question. So the next thing is we talk about connecting the dots, and there are different tools we use to connect those dots, right? But let's skip those parts. We look into it later. But let's see how we can deal with all of these um all of these errors that might actually surface when we are collecting our data set. The first one that we look out is missing data. How do we deal with missing data? All right. So when we say missing data, how do we deal with missing data? There are two ways we deal with missing data. The first one is we delete that particular row where a particular value is missing. So which is called deletion. So deletion. Another name for this technique is what is called listwise deletion. Listwise deletion. Listwise deletion. All right. The second technique we use to deal with a missing data is what is called imputation. 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 So when we say listwise deletion, what do I mean by listwise deletion? Listwise deletion means um, because a particular part of our row is missing, we delete the entire row. That is what we mean by deletion when there is a missing data. And this is the simplest of all actually. When we say imputation, instead of deleting that particular the entire row, we want to substitute that missing value with another value, which we'll actually look into so later. So when we say listwise deletion or deletion, we're deleting the entire records that are packed that the single missing value is actually present. Why when we say imputation, we are replacing that's missing value with something in our data set. We don't want to delete it. We want to impute, we want to replace that particular missing value with something. And when we say imputation, there are different methods or technique for imputation. One of the technique for imputation is there's no special technique actually for deletion. All what you have to do is look out for your missing value, look out for the record that has a missing value and delete it. And one of the problem or limitation for deletion is it most time it reduces the volume of your record. So most time it reduces the size of your record because of you removing some of these records from it because they have a missing value. Why imputation here is there are different techniques we deal with imputation. One of the techniques we deal with imputation is mean substitution. All right. So when we say mean substitution, it simply means mean substitution. So mean substitution means we check for our missing data. Then instead of deleting it, we don't want to delete it. We now replace this with the mean of every other part in our record or with the mean of all other records in the same column. We give more insight to this. Another part that we deal with here is what is called hot deck imputation. Hot deck imputation. Hot deck imputation. When we say hot deck imputation, we explain this by when we try to overlay a closed value or we try to use immediate value to replace this missing value. So that is called hot deck imputation. We'll talk more about this. All right. Why the last part that we use to deal with missing data in imputation is what is called the regression method. So regression method means we build a model to actually predict this particular missing value based on other value in other columns or based on other columns. So that is the regression. So when we say missing data, there are two ways to deal with missing data. The first way is deletion, when we try to delete the entire record because one part of the record is missing. The other part that we do or the other method for dealing with missing data is imputation. In imputation, there are three techniques to this. You have the mean substitution, you have the hot deck imputation, and we have the regression method to deal with missing data. When we say mean substitution means if a particular part of a column is missing, we want to replace this missing value with the average of all other value in that same column. For instance, what I'm saying is, let's say we have our demographic data and there's a particular column that is age. So in this age, we have 15, we have 20, we now have a particular missing part of the age. We have another one to be 25. So instead of deleting this particular part, what we want to do is we add this and this together, find the average and replace it with this particular value. So that's the mean substitution. Another part of mean substitution is what is called hot deck imputation. Hot deck imputation means we want to we want to replace this particular missing value with nearby values. So we want to see maybe it is forward method or backward method. depending on kind of method we want to use. We want to replace this value using nearby values. So that is what Ortec imputation, and that is actually what we call LOCF, which means last value carried forward. So LOCF. So what it means for a time series data when we use Ortec, it simply means our the last value in our time series doesn't change. So that is Ortec imputation. We look more into this in our future classes. Then we explain the effects, the limitation, and the advantage of this method. The last method is regression method. Regression method is very sophisticated method, a complex method, but it's at the same time the most complex and the most effective part of our imputation, because what regression does is it builds a models based on other columns in our data set and predicts those missing data based on the other values, correlation, or every other thing that is used to predict the missing value. So that is regression method. All right. Can you hear me? Can you hear me? All right. Let me confirm that. All right. So this is where we stop. This is where we stop tonight. All right. So we'll see you in our next class. Thank you very much. Have a nice day ahead.